Consider a normal software workflow where a project manager explains you a feature in Slack. Then you copy that requirement into your harness. Your agent runtime make the edits in the repository. Then you open a PR on GitHub. A reviewer asks for a change. Then you carry that comment back into your runtime again. Your harness again fixes it. Then other team member write release notes. So you can clearly see the bottleneck here. It is coordination. The project understanding is split across private sessions, chat history, code issues, and human memory. Jack Dorsey's Buzz is trying to remove that human copy and paste layer. Buzz is an open source workspace built by Block, where humans and agents can join the same channel, discuss the same project, access shared context, and act using separate cryptographic identities. It looks like Slack, it includes Git related infrastructure, it connects to your agent runtimes through ACP, Agent Client Protocol, and underneath everything is a Nostr relay. So let's give it a breakdown. At the surface, Buzz is a team workspace. You can create community inside it, you can create channels. Channels contains humans, agents, messages, threads, reactions, files, and project activities. Now the Buzz backend does not treat these activities as completely separate systems. Buzz represent activities using signed Nostr events. A message is an event, a workflow step is an event, a Git update is an event, and each event contains the event type, content, cryptographic signature, and author's public key. The event kind tells the relay and clients what that event represents. This means Buzz can add a new event without redesigning the entire transport model. Older clients can ignore features they do not understand. New clients can render additional new features. Now let's talk about Nostr, on which Buzz heavily relies for its communication. So Nostr is an open source communication platform. It stands for nodes and other stuff transmitted by relays. It has three components: a client, a relay, and signed events. Now let's see how it works. So a client creates an event, signs it using a private key. The relay receives the event, it verifies the signature and decides whether to accept it or not. Other clients subscribe to matching events and receive them over WebSockets. But using Nostr protocol does not make Buzz magically a peer-to-peer network. In the current Buzz architecture, the relay is authoritative. So if you see, the authentication, the pipeline, the handler, the HTTP bridge, the subscription registry are all handled by one Buzz relay. So that means the relay is highly authoritative. All reads and writes flow through it. So there is no automatic gossip between random Buzz relays. Now let's take a deeper look at relay. So when a message arrives, the relay performs several jobs. First, it determines which community the request belongs to. Second, it authenticates the connection. Third, it verifies the event signature. Then it checks whether the identity is allowed to perform the action. It stores durable event data. Then it distributes the event to subscribed human and agents. Finally, the event may trigger indexing, audit, logging, Git handling, or a workflow. So for each event, you may have a proper log, so you can actually trace the audit trail when needed. Now let's see a high level overview of Buzz architecture. So we can see a few components over here. We have a human client that will be sending the initial request. Then we have the Buzz relay that will be listening to every client's request through WebSockets. Then inside the relay we have Nostr protocol, and we are also storing the audit logs. Then we have Postgres that will be storing each event. Then inside Postgres we have full text search. So the guys in Block haven't implemented a more advanced level of searching like Elasticsearch. Then we have Redis for pub and sub. So let's say if a client publishes a message and a subscriber is listening to it, so that way each message does not have to be stored in the database. It is directly broadcast through Redis. Then we have S3 for storing all our files, images, and videos. Now here we have the important part. When Buzz needs to connect the workspace to your local harness, ACP enters the architecture. ACP stands for Agent Client Protocol. ACP standardizes communication between an agent client and agent runtime. Buzz includes an agent harness called Buzz ACP. On one side, the Buzz harness connects to Buzz relay through WebSockets. On the other side, it communicates with an ACP compatible runtime using JSON RPC over standard input and output. Buzz also packages something called Buzz CLI for your agents. Let's say if your agent wants to search local directories or run commands in your project, it does not need to prompt you for access or permissions again and again. It can directly execute those commands in your machine or a VM through Buzz CLI. Now, if I had to break all of this down in very easy words, so in a normal architecture, what do we have? We have a client, then we have a working backend, and then we have cache, database, or any third party storage services like S3 connected to our backend. So, how is Buzz architecture any different from this? So, first of all, Buzz does not rely, although in current architecture it only has one relay, but in future, when they expand, they are not just relying on one centralized relay. It can be decentralized by introducing multiple relays, and those relays can talk to each other. Apart from that, for each relay, we have a Nostr protocol. Now, Nostr protocols, in simple terms, if I explain it to you, think of this scenario. You can create your email through vendors like Gmail, Outlook, Yahoo, or you can create your own custom email. But how does email moves around on internet? Through SMTP, right? So in Buzz's scenario, the same concept applies. You can own a relay or get it from a relay provider. And Nostr here is a similar protocol, just like in case of email, we use SMTP. Relays are your distributed backends, and Nostr is a protocol used to wire format and identity model. So I think that makes things much more easier to understand and get a high overview of how Buzz works internally. Now there are three ways to run Buzz. You can either run it locally, you can self-host your relay, or you can use the relay hosted by block itself. Now if you go for a local setup, the relay and dependencies will run on your machine. The desktop client will connect to your local web sockets. This is more useful for development and testing rather than uh, working with a complete environment. Also, remote teammates will not be able to join your community unless you deliberately expose the relay through secure networking and TLS. So this is purely for development, and if you are contributing to Buzz itself. Then you have the self-hosted relay. This means to deploy the relay on a VM, VPS, private VPC, or a container platform. Your teammates connects through a reachable relay URL. You can control the infrastructure, storage, membership, backup, secrets management, database operations, monitoring, and availability, as well as maintenance. So all these costs you'll pay from your own pocket. So it's best when suppose your company or team doesn't want block hosting your data, so you'll deploy everything yourself. Now third approach is you are using a relay hosted by block itself, which will be working with and this is the easiest way to test Buzz. So you create or join a hosted community and connect to the supplied relay URL by your teammates. So we create a community on buzz dot. Now creating a community through Buzz supports up to 3 communities per account. Buzz hosts a relay for that community and you can invite people into that community. But the important distinction here is a user cannot join by entering the relay URL without an invitation. So let's break it down. For each account, you'll get a cryptographic identity, private key, and your public key. Then you have a community membership. So even though if you have a relay URL, so let's say if you know something like abc.buzz.com, knowing this URL doesn't let you read the messages from ABC community. You still need to be invited, so a valid key pair does not automatically grant access to a private workspace. Then channels have permissions too, so even though you are a part of a community, You may still be excluded from a private channel, just like Slack. Apart from that, each agent in your workspace have separate identities as well. Each agent receives its own key pairs, and that is how you will be able to track the audit trail for each work done by each agent. Now let's see how to install Buzz locally and get the work started. So you can either install it from buzz.xyz and you can just click here, get the app, or if you want to test it locally, you can come to their official GitHub repo and clone their repo and just set up the local environment. So we'll go to the official site and download the app. Save. So the app has downloaded. Now let's install it. Now let's create a new identity. Okay, so just like in the architecture we discussed, each user gets a private key that is given to you at the time of your profile creation. Now, this key will act as your cryptographic identity. Now, it has already detected the agent harnesses available on my local machine. Now, it's asking me to configure a default harness. I'll go with Codex, default model 5.4. Okay, so we'll create a new community as we are doing a completely new sign up. Now, because it has a local cache built for my identity, so it has directly picked up my email and has sent me a verification code. But if you are doing a completely new sign up, you just have to click on sign up, enter your email address and your password, and Buzz will send you a verification email like this. And you can just click on verify account, and you'll be directly signed in into the platform. Now, before I sign in, one thing to notice over here, the email and the password that you will be generating in the sign up process. So that email and password are not acting as your authentication layer. For authentication layer, still the cryptographic private key remains your single source of truth. Now let's enter the code, and so now let's create a community KPSX. Now, let's build up a profile. Now, by default, Buzz will give you three agent templates. One is Fizz, one is Honey, and the other one is Bumble. Now, if you have ever used Slack, you must be familiar with this interface. So, just like Slack, you can create channels and you can also create agents. Now, Fizz gave us a welcome message, and inside that thread, Bumble and Honey also replied to Fizz as well. So it was an automated message. I did not trigger it. Now, one of the key things that I liked about Buzz, although it's an experimental project, but it gives you a centralized mobile app that you can pair with your desktop app and use it completely remotely, just like Cloud Remote and Codex Remote. So basically, for the models that currently don't provide you the pairing option, you can, for let's say example, you want to run Kimi, DeepSeek, or any other Chinese model, you can directly use them with Buzz mobile app. You don't have to wait for their pairing app to come into the market. Apart from that, you can also run local LLMs. So uh, if you can see, I have already installed Gemma 4 in my system, so it has detected it. Now the main part, if you want to invite your friends or teammates, you can send them an invite link directly on any platform. their public key is added as a community member, they'll authenticate with the relay and join the permitted channels. Also, if that channel contains any agents and they have proper access, so your teammates will be able to trigger events through those agents on your machine. Your teammates won't need the agent's private key or need access to your machine or VM running the harness. The relay will act as the network's meeting or rendezvous point, but the agent host must remain online. So if your machine sleeps or the harness crashes, the agent is unavailable until it reconnects. So for reliable team use cases, I'll suggest deploying the harness to a VM. Now an agent is not permanently tied to one channel. It has an identity and can join several channels like a human teammate. So as you can see, it has a public key as we have discussed earlier. So you can directly mention it inside a channel, or you can direct message an agent, or relevant thread events can activate it. Now buzz harness keeps queues per channel and limits simultaneous prompts within the same channel. So this will basically prevent two independent channels conversation from being merged into one accidental big prompt. The harness can also restrict who is allowed to trigger an event. So for a coding agent with repository and shell access, and allowing any public user to activate it would be an outsourced incident creation. So if we go and edit an agent, you can see it has an agent name, it has a system prompt, and in configuration it is picking up the harness default. Apart from that, you can see the harness logs for each agent. Now let's start to test the functionalities one by one that are provided by Buzz. So to start with, let's first create a channel. Let's call it test. This is a test channel. Type will be ongoing, visibility will be public, template is none. Okay, so our test channel is created. Now let's start by adding an agent in the channel. Let's add honey. Now in order to trigger our agent, first we'll mention him in the chat, and then we'll give it a prompt. This is a prompt for creation of simple lead generation dashboard in HTML. Okay, so you can see it has reacted to our message and it has started working. Now we can see the activities. So it's thinking, it's running a tool call. Now it was able to generate the response, but it gave us the code directly in the chat itself. So let's prompt it again. Now, if you see here that each message gets its own event ID, so that's how Buzz is able to route multiple messages to a particular agent. Apart from that, each channel also gets its own channel ID. So that's how a single agent can be working in multiple channels and working across multiple requests. Let's see what it has created. Okay, lead pipeline. Okay, so the response works. Now what we'll do, we'll add another agent. We'll add Fizz. And we'll assign Fizz another task in the same thread. So taste skill is one of the agentic UI skill that I am using with my Codex. So Buzz in the end works with your local harness. So all of the agentic skills and all of the basic configs, it can reuse them inside your chat terminal. Now apart from that, one thing I would like to highlight as well is if you see that I am providing the agents the absolute path to my directories. I am just not tagging it as downloads. I am giving it the absolute path for that directory or that file. As if you just give it download, so your agent won't be able to find which downloads directory or which documents directory you are talking about. So it's like always good to provide it with the absolute path. So Fizz has also made the changes. Let's see. Yeah, so now it looks more clean. This is the main problem that Buzz is trying to solve. So, like, if I wanted to spawn multiple agents in a single thread, I would have been able to do that with Codex or Cloud Code Harness. But doing it across multiple provider, that is the key problem that Buzz is trying to solve over here. That no matter what your providers are, no matter what your environment is, no matter how big your project is, you can just add your teammates, add your agents, and you can start collaborating on these projects without any hassle of going through making your project or making your environment compliant for multiple providers. So you can work across multiple providers without any setup overhead. Now we'll be moving towards another key functionality that Burst provides. We'll pair our host machine with the mobile device. So in order to do that, you'll have to install the Buzz mobile app either on your Android or iOS device. Then you can click here start pairing, and then you can directly scan this QR code in your mobile device. Yes, code matches. Okay, so our mobile device is paired. Now from my mobile device, I'll try to message one of our agents. So if you see, this is the message that I sent from my mobile device. Now let's move to another key feature that Buzz claims to solve, that is Teams collaboration. So I've just installed Buzz on one of my other devices and I'm just copying the link and sending it to that device. Now if you see here, I have clicked on the invite that I sent from my host machine and this interface open. I have just installed Buzz. Let's accept the invite. Open Buzz. Now let's create another profile. Let's name it Bob and no image. Take me to Buzz. Okay, so now we are in the same community. You can see here KPSX. Now, if I come back to my main device, you can see that Bob is currently the member of my community. Now, let's try to add him on a channel. Now, let's add Bob to this channel. Okay, so Bob is added. Now, if we come back to our another device, we can see the test channel has been added into Bob's workspace and we try to start our conversation with Fizz. Now here, because I have not configured any provider in this device, that is why Fizz is giving this error. That is why you can currently see two Fizz in the same channels. One belongs to Bob's device and another to my device. Now in order to give Bob the access to the Fizz agent that is running currently in my device, what I'll do, I'll go to agents, then I'll click on the agent, edit, advanced. Now who can send instructions? Let's add Bob, add, save changes, and now let's test if Bob is able to send messages to Fizz. Now what I'll do initially is I'll remove the redundant Fizz. So currently I think Buzz does not support uh, remote access to agents. As you can see, still I'm not able to access Fizz remotely. After checking the GitHub repo of Buzz, I saw these two issues. Managed agents are only mentionable from machine that runs them, which is currently open. And the second one, remote agent missing from @ mention autocomplete across machines. which is also currently open. And as Buzz is an open source project and currently in its experimental stages, so I think these things can be expected. Now we talk about performance, reliability, and production readiness. Buzz adds hops compared with talking directly to your harness. A direct session may be you open terminal and start your harness session, while Buzz introduces authentication, signature verification, persistent context retrieval, and additional network travel. Therefore, Buzz is not primarily latency optimization. It is a coordination optimization, and that also in experimental stage, as we just saw. So, for one developer doing one task, direct harness is simpler. For several people and agents sharing work, the extra infrastructure may reduce total hands off time. So now is Buzz able to solve the coordination problem between humans, agent, workflow events, code activity, and approvals? Well, with whatever we have learned, Nostr provides identities and signed events. The relay enforces the workspace boundary. ACP bridges workspace events into your agent runtimes. Tools perform the actual work, and the architecture is coherent. Buzz is attempting to become a communication platform, agent orchestration layer, workflow system, and self hosted infrastructure product. Now, each one is a task in itself, and together they create a large operational and security surface. So, would I use it today? For research and experiments, yes. For one bounded internal project, yes. For a small technical team comfortable with early software, possibly. Would I replace Slack across a company with it today? Definitely not. But what I see is very much appealing and can be used in the industry heavily in the future. Once it comes out of its experimental cave, of course, it is one of the clearest experiments in what a shared workspace for teams and autonomous software could become.